Hello. Now we will study the electric dipole and dipole moment. When we talk about dipole moment, it is defined by P. It's a vector quantity. Now let's first talk about electric dipole. So what is electric dipole? So a combination of two equal and opposite charges. The combination of two equal and opposite charges are defined as electric dipole. So this is your electric dipole. This is known as electric dipole. So there is plus Q charge and there is this minus Q charge. The combination of these two charges, when there is one plus and one negative, and they have to be equal magnitude wise, and the sign has to be opposite. So these two charges are defined as electric dipole. The distance between these two charges I'll define as 2 times of L. Why 2? That we will learn later on, just to simplify the formulas which are going to come. Okay. The question comes, okay, this is electric dipole. The main question comes, why we are studying this electric dipole? Because we already know how to calculate the electric field due to the single charges. We already know how to calculate potential. We already know how to do the things corresponding to single charges. So why we need to study electric dipole? The answer is, in majority, whenever we are seeing the electric field, we are seeing the electric field not because of single point charge, we are seeing the electric field because of the dipoles. The thing is, if you see any matter, each and every matter is the building block of each and every matter is atom. And when we talk about the atom, there are positive charge as well as negative charge. So every atom consists of a nucleus and electrons which are revolving around the nucleus. Okay, so this nucleus, that has the positive charge, and the electron which are revolving around the nucleus, they are the negative charge. Okay, so now there are two possibilities. So if, let's talk about atom. So there is this nucleus. So I'm having this nucleus, all positive, and there are electrons which are revolving around the nucleus. Multiple electrons, I'm just showing only one right now. The multiple electrons are revolving around the nucleus. So one possibility is, since all these electrons are revolving around the nucleus, so they are moving. So there is no fixed point where they are not stationary basically. So if all of these charged particles are moving and nucleus is fixed, electrons are moving. So what I have to do, this system we have to define by the center of charge of nucleus and the center of charge of negative charge particles. So we have to take the center of these electrons and the center of nucleus. Obviously, center of nucleus will lie at the center of nucleus itself. So there will be this center of positive charge and there will be one center of electron. Now there are two possibilities. What are those two possibilities? So when we take the center of these electrons might lie on the center of the positive charge itself. So there is this center of positive charge and there is this center of negative charge. They are lying onto each other. That will be the case for inert particle. Inert gases, or we call them. So in case of inert gases, when we talk about the electron, the center of electron or center of electron lie at the center of the positive charge. So there is no dipole there. But in majority of cases, except the inert gases, in majority of cases, when you will look for center of nucleus, which is the center of positive charge, and the center of electron, they will not lie onto each other. They will be a little bit separated. So you see this atom is basically the basic electric dipole, because there is a one center of positive charge and there is one center of negative charge, and they are placed at some distance. So the atom is the most basic form of electric dipole. So that's why we want to study the electric dipole, because you see, each and everything is made up of atoms. If we know the behavior of the atom, if we know how that atom is going to create the electric field, how that atom is going to create the electric potential, we can calculate the electric field and potential due to any body, because that's the basic building block of each and every matter. So when we study the electric dipole, we study the electric dipole so that we can study the atoms, the behavior of the atoms or effect of the atoms. Okay, so that is the reason we study the electric dipole. So a point positive charge, a point negative charge, when they are separated, this system is known as electric dipole. Okay, so now we have to define the dipole moment, because this is my system. Then corresponding to this system, we define a vector quantity, that is dipole moment. Dipole moment, and this is defined by P, which is a vector quantity. So when we have a positive charge as well as the negative charge, and the distance between these two, if that is 2L, in that case, the dipole moment is defined as the magnitude of charge, obviously one charge, multiplied with distance between the two charges, that is 2L I'm taking here, n cap. N cap is to define the direction. So it will be 2 times of QL n cap, that will become your dipole moment. And the direction of this n cap, will be from negative to positive charge. So this is opposite to electric field. That's how one should memorize. I memorize like that. So electric field is from positive charge to negative charge. Dipole moment is from negative charge to the positive charge. So in this case, dipole moment will be in this direction for this system. Okay, so this is something we define, so that the next thing like electric field and potential, when we will be calculating those things, we will be calculating those things in terms of dipole moment. So this is because this dipole moment depend upon some intrinsic property of the system, charge and the distance. And when we talk about the atom also, it will depend upon the intrinsic property of the atom, how much charge is there in the atom and what are the relative distances between the atom. So the dipole we define as the system of two charges, opposite charges, magnitude-wise they have to be same, and that's how we define the dipole moment. Okay. Next we will study the electric field as well as the potential due to the dipoles. Okay. Thank you.